Everyone, very good evening and welcome to the BYJU'S Exam Prep. This is Sanjay Rathi, and now today we are going to discuss operational amplifier and its application. And this is a part of GATE AIMER'S series 2023, a free crash course for GATE 2023. Okay guys, and let me know that sound quality, picture quality, everything is fine. Yes please. First of all, inform me that sound quality, picture quality, everything is fine. Okay. If everything is fine, then now in this session we will discuss some important application of operational amplifier, and you will get the command over the concept with what some important numericals. Okay, so Crystal, yes, it is clear. Thank you for your feedback, Madhu. Now operational amplifier and second topic, that is what waveform generator. Tomorrow Monday I will cover what waveform generator. Waveform generators means what? Bistable, monostable, astable, multivibrators, triangular wave generator, and what? Oscillators, right? Barkhausen criteria. And here in this session I will give you the idea that we are going to cover the application of operational amplifier. Okay, then first of all, this is my small introduction. Myself Sanjay Rathi. I am having around 21 plus years of teaching experience. I have qualified and selected for engineering services exam. My rank was AIR 16 in ECE 2005 and AIR 21 in ECE 2008. And I have mentored more than 1 lakh students for this particular exam. Okay guys. अब देखो गेट का टाइम तो ज्यादा बचा नहीं है. कई लोगों को लगेगा कि सर मेरी प्रिपरेशन पूरी है या नहीं है. कई लोगों को क्या 90% से ज्यादा लोग ये सोच रहे होंगे कि अब क्या कंटिन्यू किया जाए या क्विट कर दिया जाए. राइट, अगर आप ऐसा सोच रहे हैं देन दैट इज द सेशन फॉर यू. ओके गाइज, नो नीड टू क्विट द एग्जाम. सिंपली रिवाइज ईच एंड एवरीथिंग, ट्राई टू सॉल्व न्यू क्वेश्चंस, try to solve previous year questions, and once you will be able to solve the basic questions, then moderate question, then tough question, definitely you are going to get the good rank in coming exam. तो बिल्कुल छोड़ने की जरूरत नहीं है. हाँ बिल्कुल, अंकित सर हमारे साथ हैं. वेरी गुड इवनिंग सर. राइट, तो यही मैंने बोला ना, अब छोड़ने की जरूरत नहीं है, अब परफॉर्म करने की बात आ रही है. तो अगर आप डर कर छोड़ देंगे तो पूरी तैयारी बेकार हो जाएगी. Now that is for you BYJU'S Exam Prep Mega Mock Challenge, All India Open Mega Mock Test for GATE 2023. Okay, and my dear friends, that is for you from 13th December to what 20th December. Register now. You can register on our official website or what BYJU'S Exam Prep app. And please give all the mock test and we will provide you the solution as well as video solution for all the questions. Okay. So that is from 13th December to 20th December. And that is the time for mock test. Then guys, I will cover, these are the content table. In this session, we will cover question from all the topics. That is, first topic is what? First question on slew rate. Everyone please in the comments box, please mention what do you mean by the slew rate? Right? Sanjay Rathi mat bolna, SR hai. That is the SR, slew rate. Second one is what? Voltage to current converter, V to I converter. That is another application of operational amplifier. This is very important one. Third is what? Differential amplifier. We will solve one question and you will get the idea about CMRR, differential gain and common mode gain. Then next one is on logarithmic amplifier. One question on logarithmic amplifier. This is a non-linear application of the operational amplifier. Here we are using non-linear characteristics of diode. We are connecting diode, right, in feedback path, and we are getting the logarithmic amplifier. Next topic. After that, filters. No doubt we can design the band pass filter, band reject filter, all pass filter, high pass filter, low pass filter by using operational amplifier. These are known as active filters. Right, so that is in our syllabus, and again this is very important topic. Then after that you will get the idea about the gain bandwidth product with one numerical. What is the meaning of this and what is the gain bandwidth product, right? And that is the figure of merit of any amplifier. So let me know that what about the operational amplifier? It is a RC coupled or direct coupled amplifier. Yes, please tell me. Vetri, Madhu and 420 Bruce Lee. Please tell me. What about the operational amplifier? It is the direct coupled or RC coupled? Sir, is this the content sufficient to crack the gate? Yeah, my dear. Yes, if do you want to get the top rank in gate exam or simply want to qualify? Tell me. No doubt. In the month of December and month of January, we will cover almost all the important topics, all the crucial topic here on this website, on this YouTube channel. Okay, please subscribe our channel. Now, use of operational amplifier in biasing. This is a very important and conceptual topic I will cover here. Then offset voltages and current. One question on offset voltages and currents, and one question on what? Input bias current. One question on input bias current. This to normally question on this topic for instrumentation branch, but this is in the syllabus of electronics student as well as electrical students. Okay, but important for instrumentation branch. Yes, Madhu, direct coupled. Operational amplifier is what? Direct coupled. Right, Madhu, your answer is correct. Direct coupled amplifier. So differential amplifier, and that's why we are designing what? Differential amplifier. Right, and the most popularly used differential amplifier is emitter coupled differential amplifier. That is the first internal stage of operational amplifier. Remember, operational amplifier is a multi-stage amplifier. Operational amplifier is a direct coupled amplifier, and operational amplifier is basically a voltage amplifier. Okay, input resistance is very high, output resistance is very low, voltage gain is infinite. These are the characteristics of operational amplifier. Right, now we are going to solve some important numericals on operational amplifier. First, now tell me what is the answer for this question. That is the question on slew rate. For an operational amplifier having a slew rate of 2 volt per microsecond, that is the unit of slew rate is what? Volt per microsecond. Then what is the maximum closed loop voltage gain that can be used when the input signal varies by 0.5 volt in 10 microsecond? Varies by 0.5 volt in 10 microsecond. That is the question on slew rate. Everyone, try to give me the answer in comments box. I am going to solve this question. Now, what is the slew rate? Remember, 1 minute. Try to solve this question. Okay. Slew rate means the maximum rate of change of output voltage under closed loop condition. That is the slew rate. dV naught by dt max. Now you can write dV naught by dVi. We are multiplying with the dVi. We are dividing by the dVi max. And this dV naught by dVi is called closed loop gain. Closed loop gain. So slew rate is also written as closed loop gain into rate, maximum rate of change of what? Input voltage. So that is the formula. We will use this formula to solve this particular question. What is asked here? Closed loop voltage gain that can be used when the input signal varies by 0.5 volt in 10 microsecond. 0.5 volt in 10 microsecond. So what is the dVi by dt? The rate of change. 0.5 volt in 10 microsecond. Right? So what is the answer? It will become 0.05 volt per microsecond. 0.05 volt per microsecond. That is the rate of change of input signal. Right. Now what is the closed loop gain then? The closed loop gain is given by ACL is equal to slew rate divided by dVi by dt max. What is the slew rate? What is the unit? 2 volt per microsecond. And what is the unit of rate of change of the input? 0.05 volt per microsecond. Unit cancel out. And now you will get the dimensionless quantity, that is the slew rate, 200 divided by 5. And that is 40. That is what? 40. Okay. So which answer? B is the correct one. B is the correct one. Remember, this is the MCQ. There will be negative marking. If it is 1 marks question, 1/3 negative marking. If it is 2 marks question, then 2/3 negative marking. It is a MCQ and answer is what? B. Very simple. That is the slew rate. Now, so remember, this is the formula. Okay. Next one. Now the question on what? Voltage to current converter. Second application is what? Voltage to current converter. What is the load current IL in the circuit below? Okay. Number of times straightforward question on this topic. Right. These are the standard circuit. Tell me what is the answer for this particular question. Then I will give you the different cases for this. Okay. Different cases for this diagram. और एक बार जरा यार लाइक कर लो, सब्सक्राइब भी कर लीजिए चैनल और शेयर तो कीजिए लिंक अपने ग्रुप में, so that student will join the session now. Okay. Now, what is the load current IL in the circuit? IL. This is the 200 ohm. This is called load RL. And that is RF. This is R1. This is 10 volt battery is connected here. 10 volt signal is connected here. This is called RP. Normally, this is a general formula: RF, R1, RP and R2. And this is the RL actually, 200 ohm. What is the load current means? What is the current here? IL. This is a standard diagram for voltage to current converter with grounded load. Here the load is connected to ground, and that's why it is called the grounded load. Now, what is the load current in the circuit? Okay, answer A, answer B, answer C or answer D. Which one is correct? Again, it is a MCQ. Multiple select question. Only of 1 marks. Why? Because it is a standard circuit. Standard circuit, directly we have to give the answer within 10 seconds. Okay guys. Now, remember, in this circuit, first case, always check this. This is called balance bridge condition. This is called what? Balance bridge condition. RF, R1, RP, R2. This is RL. Always check this. RF by R1. If RF by R1 is equal to RP by R2, then RF by R1 is equal to RP by R2. If this is satisfied, then the current will be independent of RL, and that's why it is called voltage to current converter. In normal circuit, it is not called voltage to current converter. Why? That was the question. That was the question in objective. Suppose I am connecting a battery here, V volt. Now, definitely I am going to get the current here. What is the V divided by RS plus RL? No doubt, this voltage is converted into current. We are connecting the battery, we are getting the current. But it is not the voltage to current converter, because in this case, IL depends upon the value of RL. Right? But in this diagram, when I am calculating, when this condition is satisfied, RF by R1 is equal to RP by R2, the formula for the current is simply minus Vs by R2. R2 means this resistor. Always remember this resistor. Since the input is connected to inverting terminal, then put the negative sign and it will become minus 10 divided by 1. Answer is what? Minus 10 milliampere. If suppose I am changing the value of this load, the current will not change because it is independent of RL, and that's why this circuit is called voltage to current converter. Remember that. If this condition is not satisfied, if RF by R1 is not equal to RP by R2, then this is not a voltage to current converter. This condition should be satisfied. Second important thing about this diagram, if the input is connected to non-inverting terminal, for example, input is given here, everything will remain same. Check the condition and directly you can write the answer. IL is equal to I0 is equal to Vs by R2. So if the input is connected to non-inverting terminal, this is the non-inverting terminal, then Vs by R2. Vs by R2. Okay. So that is about this diagram. Sir, is it an ideal amplifier? Yes, we can say, Madhu. Is it a, means which one is the ideal amplifier? Operational amplifier, right. Try to understand. When we are designing voltage to current converter or current to voltage converter, integrator or differentiator, right, or a number of applications like logarithmic amplifier, anti-logarithmic amplifier, Madhu, then we are choosing operational amplifier with gain what? Highest gain. What is the open loop gain of operational amplifier? 10 to the power 6. 10 to the power 6. And after that we are applying the negative feedback. So when we are applying the negative feedback, so definitely the gain will reduce. The gain, closed loop gain is normally 10. You can understand RF by R1. What is the RF by R1? 10, 20, 100 maximum, or 1 plus RF by R1. That is the gain. Now tell me, what about this 10? 10 is very less than what? 10 to the power 6. 10 is very less than 10 to the power 6. This is the closed loop gain. This is the open loop gain. So we can assume that let the 10 to the power 6 is infinite. Yes or no? Tell me, Madhu. 10 to the power 5 times higher than that value. So yes, we can assume let the this is a very high value. When this is a very high value, we are assuming it infinite, and we are normally saying that operational amplifier is ideal. Operational amplifier is what? Ideal. Yes. So in case of negative feedback, normally we are choosing what? Ideal operational amplifier. But in case of positive feedback, if sometimes it is written that we are choosing the ideal operational amplifier. Everyone give me the answer. If the operational amplifier is ideal, already gain is infinite, so why we are giving the positive feedback? What is the purpose of positive feedback? Only one purpose, increase the gain. So already the gain is infinite, so why we are providing the positive feedback to the operational amplifier? Right, so in next class I will discuss. Monday 7:30 to 9 I will discuss this case, right? What is the positive feedback in case of operational amplifier? Okay, so this is the ideal operational amplifier and that is the ideal condition and so on. Answer, remember this answer. Next topic. Now third question is on differential amplifier. थर्ड क्वेश्चन इज ऑन डिफरेंशियल एम्पलीफायर. भाई जाइए मत, अभी क्लास अटेंड करते रहिए, अभी आपके फटाफट टॉपिक आप लोगों के तैयार हो जाएंगे. नाउ टेल मी, डिटरमाइन द आउटपुट वोल्टेज ऑफ एन ऑपरेशनल एम्पलीफायर फॉर इनपुट वोल्टेज ऑफ 150 microvolt and 140 microvolt. The amplifier has a differential gain of 4000 and value of CMRR. This is called common mode rejection ratio is 100. Then what is the answer? What is the answer for this question? Now remember, this is a differential amplifier and we are getting the output. Here we are giving the two inputs V1 and V2. Output is equal to, for any differential amplifier, is ADVD plus ACVC. ADVD plus ACVC means it is a practical differential amplifier. AD is called differential gain, AC is called common mode gain, and ideally this AC should be equal to what? 0. What is the VD? V1 minus V2. What is the VC? Common mode or common signal or average signal. So what is the average? V1 plus V2 by 2. V1 plus V2 by 2. This is called common mode signal, a common mode gain. This is called differential gain. This is called difference signal. This is called common mode signal. Okay. What is the CMRR? CMRR is nothing but mod of AD by mod of AC. So in this particular question, output is required, AD is given, AC is not given. You can find the AC from this. So what is the AC is equal to? AD by CMRR. Remember that. AD by CMRR. Ideal value of CMRR is infinite and ideal value of AC is what? 0. But in this question it is very less, 100, and that's why 4000 is the differential gain upon 100 cancel out, 40 is the common mode gain. 40 is the common mode gain. Now what will be the output? V0 is equal to, now what is the VD? V1 minus V2, that is 150 minus 140, that is equal to 10 microvolt. Watch this. 150 minus 140, that is 10 microvolt. And what is the average value of this? Vc is equal to V1 plus V2 by 2, that is 150 plus 140 divided by 2, that is nothing but 145 microvolt. What will be the output? This is given as 4000 into 10 microvolt. Remember, that is a 10 microvolt plus 40 into 145 microvolt. Now you can convert it into millivolt because answer is given in millivolt. You can multiply it with the 10 to the power minus 3 and you will get the answer. Please, calculation is your part, and when it is multiplied with the 10 to the power 3, and it is converted into what? Millivolt. Microvolt is converted into millivolt. What is the answer? 45.8 millivolt. 45.8 millivolt. So this type of questions from what? Differential amplifier. Differential amplifier. Right. One type of question on differential amplifier. What is the error? So this is the answer for this question. Remember this. This is the error actually. This is the error. So sometimes they will ask what is the percentage error. Percentage error means ACVC is the error and wanted quantity is ADVD into 100%. That is called error. Error in calculation. Or AD by AC is CMRR, and that's why it will become 1 by CMRR into VC by VD into 100%. That is error in calculation for differential amplifier. If the CMRR is infinite, that is AC is 0, then error will become 0. Error will become 0. That will be the answer. Yes. आगे समझ में? So that is about what? That is about differential amplifier. Last but not the least question, that is on differential amplifier. Again, we will discuss next one. Then, what is the standard circuit by using the operational amplifier? Quick revision of this. Quick revision of this. This is the standard circuit of differential amplifier. If you have the idea about that, then draw the diagram on your rough sheet. This is the differential amplifier. Right? This is RF, this is R1, this is R2, this is R3. Here we are connecting the V1, here we are connecting V2, non-inverting terminal, inverting terminal, and that is the V0. That is the differential amplifier by using operational amplifier. Always remember, first of all, check the condition. RF by R1 is equal to R3 by R2. If RF by R1, this is called balance bridge condition, RF by R1 is equal to R3 by R2. If this condition is satisfied, remember CMRR is infinite. So Madhu, tell me what about this operational? Manisha, tell me. Madhu, Manisha, Hiba, Arif, how are you? And Ankit sir भी है हमारे साथ में, बैटरी सूर्या भी है. Please tell me, what about this differential amplifier? If the CMRR is infinite, then I can say it is the ideal differential amplifier. Ideal differential amplifier. In that case, remember, output is only ADVD and VD is RF by R1 only. RF by R1 and VD is what? V1 minus V2. Non-inverting terminal minus inverting terminal voltage. Non-inverting minus inverting terminal voltage. Directly you can give the answer for this question. Okay. If RF by R1, right? 1 minute. If RF by R1 is not equal, then not equal. If RF by R1 is not equal to R3 by R2, then directly we have to write the output. Then we are using the superposition theorem. We are writing the voltage at this point is multiplied with 1 plus RF by R1. What is the gain? 1 plus RF by R1 into voltage at this point. According to voltage division rule, what is the voltage? R3 upon R2 plus R3. R3 upon R2 plus R3 into V1. That is the voltage at this point, R3 upon R2 plus R3, and it is a non-inverting operational amplifier, and that's why it is multiplied with 1 plus RF by R1 minus RF by R1 into V2, because it is an inverting terminal, minus RF by R1 into V2. V2. That will give you the formula for what? Differential amplifier directly. Sometimes, number of times that is not satisfied, this condition is not satisfied, then you have to find it like this, right? Or remember that this is a standard formula for A1 V1 plus what? A2 V2. Now you can compare this quantity. This quantity is A1 V1. I am highlighting this point. This is what? A1. Okay, this is visible, right? This is A1. Okay, and the remaining, that is A2 is what? Minus RF by R1. A2 is what? Minus RF by R1. So for practical differential amplifier, AC is not 0. So then we have to find the A1, then we have to find the A2, then we can find the AD, and we can find what? AC. What is the AD and AC? The general formula for that, चलिए भाई गलत होगा तो बता देना जरा. AD is given by A1 minus A2 by 2, and AC is given by A1 plus A2. A1 plus A2, that is the formula for AD and AC. So that is all about the practical differential amplifier. First of all, write down the formula, get the value of A1, get the value of A2, then by using this, get the value of AD, get the value of AC, then you can find the CMRR, mod of AD by AC. And finally, if it is asked the CMRR in dB, CMRR in dB, so 20 log of AD by AC. Log base to 10, not some students are using natural log. Natural log nahi, log base to 10. Then you will get the right answer for this question. CMRR. Always remember, if the CMRR is given in dB, CMRR is given in dB, then AD, if it is given in dB, minus AC in dB. Why we are using the logarithmic scale? Because we want to avoid what? Multiplication or division. Then if it is given in dB, then or AD or AC is given in dB, directly we can subtract dB AD minus AC in dB. So that will become the formula for CMRR. Okay, next topic. चलिए, आपको बात समझ में आ गई तो एक बार जरा लाइक कर लीजिएगा सेशन. आप देखते हैं नेक्स्ट वन. व्हाट इज द नेक्स्ट टॉपिक? So this is all about the differential amplifier, right? This is the error, how to find the formula, A1, A2 and so on. Next one, logarithmic amplifier. Next application is what? Logarithmic amplifier. Now, when we are connecting the diode in the feedback path, this is called logarithmic amplifier. So what is the question? First of all, give me the answer for this question. In the operational amplifier circuit shown, assume that the diode current follows the equation I is equal to Is exponential V by Vt. Diode current, where V is the voltage across the diode and Vt is the volt equivalent of temperature and Is is the reverse saturation current, non-linear equation. For Vi is equal to 2 volt, this is the Vi connected here. For Vi is equal to 2 volt, V0 is V01, and for Vi is equal to 4 volt, V0 is V02. The relationship between V01 and V02 is, क्या किया मैंने लास्ट क्वेश्चन में? लास्ट में मैंने आपको हिंट कर दिया इस क्वेश्चन का. लॉगरिथमिक एम्पलीफायर, व्हाई वी आर यूजिंग द लॉग? टू अवॉइड व्हाट? मल्टीप्लिकेशन एंड व्हाट? डिवीजन. So here it is a multiplication and so on. So my dear, in this diagram, one thing, watch this diagram. Logarithmic amplifier, this is Vi, right? Remember direct formula for that. V0 is equal to, because it is connected to inverting, always we are getting the negative sign, Vt log of Vi upon I0 into R, this R. Am I correct? Okay. Where what is the VI? VI is the input signal. VI is the input signal. VI. Monisa is giving the answer. What is the answer? B. You are giving the B answer. V02 is equal to E. Okay. I will check. Now previous question. You are giving the answer for previous question. No. For previous question that was the A. Okay. We will check. Now always remember V0 is equal to minus Vt log of Vi by I0 R. Now in first case, what is the V0 1? It will become minus Vt log of, input is given as 2 volt and Vt will remain same. 2 divided by reverse saturation current R will remain same. This R will also remain same. Now what is the V02? The input is changed to what? 4 volt. So Vt log of 4 divided by I0 into R. Let this is for Vi is equal to 2 volt. That this is Vi is equal to 4 volt. That is given in the question. V01 and V02. Now my dear friends, in log, normally we will do what? Subtraction or addition. To subtract it. So what is one subtraction is given in the option? V01 minus V02. Suppose I am subtracting V01 minus V02. Matlab means equation. Let this is the equation. It is we are subtracting this equation. Now when I am subtracting, it will become what? Minus Vt log of 2 divided by I0 R. Minus of minus, it will become plus Vt log of 4 by I0 into R. So what is the common here? V01 minus V02 is equal to Vt is common here. And it will become log of, now plus is 4 by I0 R upon what? 2 by I0 into R. I0 R cancel, 4 by 2 is 2, that will become log 2. Vt log 2, that is the answer for this question. Vt log 2. This is a logarithmic amplifier actually. Vt log 2. The output depends upon the log of the input. Okay, right. But remember, no doubt it is a logarithmic amplifier. Sometimes they will give the question, simple question like this. What is the highest value of the V0? They will ask. Highest value of V0 they will ask. No doubt. What is the maximum possible value of the V0? Sometimes this type of questions they may ask. Remember, if logarithmic amplifier is not mentioned and output is asked, when the diode is forward bias, this is the drop across the diode. There is a negative feedback. According to virtual short concept, Vp is equal to Vn is equal to 0. Vp is equal to Vn is equal to 0. Write down the KVL from this point to this point. 0 minus V0 is equal to Vd. 0 minus V0. So what is the V0 is equal to? Minus Vd. And what is the drop across the diode? If it is a silicon diode, 0.7 volt. So answer is minus 0.7 volt. 0.7 volt. Right. Minimum well. Arey my dear Ritesh, you are watching the YouTube sessions and so on. Simply now it is the time to give the GATE exam. Last 1 month we have. No doubt your question is valid. But this type of questions, what? Before exam means 1 year or 2 year planning. Now we have only 1 month. Right? December and what? January. Why you are bothering about the seats and so on? First of all, try to get best rank. Okay? Give your best. वो भी बोलते हैं ना, कर्म कर और फल की चिंता छोड़ दे. तो छोड़ दो चिंता आप. अब ज्यादा टाइम नहीं बचा है. Now we have only December and January. Right? Give your best. Once you will get the rank, once paper over, then we will decide. Don't worry about that. अभी आपके पास एक ही हाथ में है कि अच्छे से पढ़ो, अच्छे से दो. सपोज मैं बोलूंगा एक सीट है तो आप डिमोटिवेट हो जाओगे. अरे एक ही तो सीट चाहिए आपको, जो चाहिए वो बताओ ना. हमेशा दूसरों से ही पूछते रहोगे क्या? दूसरों से पूछना ठीक है, लेकिन आपको क्या चाहिए? आपको जो चाहिए अगर वो मिल जाएगा तो फिर बढ़िया है. इच्छा तो रखेंगे ना, सबको इच्छा तो होती है, लेकिन टारगेट सेट करने का टाइम 2 महीने थोड़ी ना डियर. आप बस काम करो, 2 महीने में रिजल्ट्स दो, उसके बाद आपको पूरा डेटा मिल जाएगा. डोंट वरी अबाउट दैट. जस्ट आफ्टर पेपर वी विल गिव यू द आइडिया अबाउट विच टाइप ऑफ रैंक्स एंड कहां पर क्या मिलेगा, और वो हर साल वेरी करता है. राइट? तो आप अपना बेस्ट दीजिए मेरे हिसाब से. भाई मैं तो ये चाहता हूं कि आप अपना बेस्ट दीजिए, बेस्ट तरीके से परफॉर्म कीजिए। राइट, अब आ जाओ जरा, ये है ना टाइम हो गया क्विक रिवीजन का। बिल्कुल गलत नहीं हो आप, बिल्कुल सही हो कि अब मुझे क्या चाहिए, लेकिन अभी आप गेट दे रहे हो तो बेस्ट दीजिए। अब आते हैं नेक्स्ट क्वेश्चन में। देखो ये लॉगरिथमिक एम्पलीफायर हो गया, ये क्वेश्चन जब भी आए गिव द आंसर -0.7 वोल्ट। now that is the question on what filter. This is the question on filter. Assuming the operational amplifier shown in the figure to be ideal, the frequency at which the magnitude of V0 will be 95% of the magnitude of V in kilohertz. Right? Tell me what will be the answer. Now watch this diagram, this portion. This portion is actually this one. This is a this is a low pass filter, right? And for any low pass filter, the standard formula is given by 1 upon, for passive filter, I am talking about the passive filter, V0 by V in, 1 plus J, right? And this is F is the instantaneous frequency, Fc is the cutoff frequency, where Fc is given by 1 by 2 pi RC. 1 by 2 pi RC. This is R, this is C, this is R, this is C. You can find the Fc from this formula. Okay, this is the standard formula. Now it is followed by what? Now it is followed by non-inverting operational amplifier. Then, sir, can you solve one problem on slew rate? How to calculate the maximum? Yes, I will give the idea about. ये तो हुई ना, ये थोड़ा काम की चीज पूछे. Solve one problem. I am going to solve one problem on that. I am not having the problem here, but I will give the how to find the maximum frequency of operation. Okay, Gopi, wait for 1 minute. Now R and C, 1 upon 1 plus J F by Fc, 1 by 2 pi RC. This is low pass filter, passive filter. Passive filter is followed by a non-inverting operational amplifier because its output V01 is connected to positive terminal. What is the gain of this? 1 plus RF by R1. This is the non-inverting operational amplifier, RF, and this is the R1. Now, and that's why the overall gain of this figure will become V0 by Vi is equal to V0 by V01 into V01 by Vi. So what is the V0 by V101? 1 plus RF by R1. 1 plus RF by R1. And what is the gain? V01 by this one for this figure. Already I have given 1 divided by 1 J by F by Fc. This is the standard formula for this filter. Once you will get the standard formula, now this is the V0 by Vi. What is the magnitude of this gain? The magnitude of this gain will become is equal to 1 plus RF by R1. Now you will get one standard formula, root over 1 plus F by Fc square. This is the cutoff frequency. Now what is asked? The frequency, the instantaneous frequency at which output will become 95% of input. Output will become 95% of what? Input. That is the question. So V0 by Vi will become what? 0.95. Right here 0.95 is equal to 1 plus RF. What is the RF? 1. What is the R1? 1. 1 by 1, that is become 2. Root over 1 plus, you have to find the frequency at which it will become 0.95 in terms of what? Cutoff frequency. Now solve this question. It will become 0.95 here, root over 1 plus F by Fc the whole square is equal to 2 divided by 0.95. 2 divided by 0.95. Now it will become F by Fc the whole square is equal to 2 divided by 0.95 square minus 1. So what is the formula for F? Formula for F will become Fc root over 2 divided by 0.95 the whole square minus 1. In next time you can directly use this formula. That is the maximum gain divided by what is required here. Maximum gain is 2. And what is the gain required here? 0.95. So maximum divided by required square minus 1 into what? FC. That will give you the frequency at which you can use any for any gain. Suppose the gain is required 0.95, 0.5, 1, 2, root 2, something else. So this is the maximum gain divided by that minus 1, directly cutoff frequency. Remember this formula. Now what is the cutoff frequency from this? 1 by 2 pi RC. What is the value of R and C? 10 kilo ohm, 10 nanofarad. Now if you have the 10 kilo ohm and 10 nanofarad, then cutoff frequency 1 by 2 pi 10 kilo ohm, 10 into 10 raised to power 3, 10 into 10 raised to power minus 9, 10 nanofarad. You can put this value and now you will get the value of frequency at which it will become what? That is 95% of the magnitude of gain. You will get around 3 kilohertz. You check my answer. I think this is the right answer, 3 kilohertz. Calculation is your part. Already I have given each and everything. Put the value of FC here and then put the value and you will get the F for this value. Okay. Okay guys, that is the answer for this question. तो देखो क्वेश्चन ये नहीं बोला है व्हाट इज द गेन विल बिकम मैक्सिमम रूट 2 टाइम्स एंड सो ऑन, राइट? तो गेन इज व्हाट 0.95 and actually maximum gain is what? 2. Maximum gain is 2. Next question. So this is a question on active filter. So one student demands that sir, one question on slew rate. Okay, maximum frequency of operation. So before everyone take the screenshot of this, that is the question on gain bandwidth product. Gain bandwidth product. And with this question I will give you the idea about what direct coupled amplifier. Operational amplifier is basically a direct coupled amplifier. Okay guys, now what is the slew rate? Slew rate means SR, that is the maximum rate of change of output voltage. Okay, now we are writing dV0 by dVi into what? dVi by dt max, right? And this is called closed loop gain into what? dVi by dt, that is the slew rate. Okay, this is the formula. Now suppose input is given, let the input is given as sinusoidal signal. If the Vi is given as Vm sine of omega t, if this is the input, okay, so Gopi, now watch this. So what is the rate of change? dVi by dt is equal to Vm omega cos of omega t. Differentiate this cos of omega t rate. What is the maximum value? Let at omega is equal to omega m, cos omega t will become 1. That is called maximum value. So what is the maximum value? It will become Vm omega m. This is the maximum frequency for which this dVi by dt will become maximum. Put this value here. So what is the formula for this? Will become slew rate is equal to mod of ACL into what? Vm into omega m. Vm into omega m. Now that is the new formula. Okay, from this formula you can get the maximum frequency of operation. So what is the maximum frequency of operation? Omega m, that is 2 pi fm, that is equal to slew rate divided by ACL into Vm. ACL into Vm. So in a particular numerical, right? For example, I am giving you one numerical also. Like this is the operational amplifier. Not so beautiful, but okay, चलेगा. Concept समझना है हमें. This is the V0. This is the ground. Okay. Now tell me, I am here. I am connecting one input. That 0.2 sine of omega t, and this is given as 10. Tell me, what is the closed loop gain for this? And if I want to get the maximum frequency of operation for this particular diagram, slew rate, normally the slew rate is given as 2 volt per microsecond. Suppose it is given for this question that let the slew rate is 2 volt per microsecond and find the maximum frequency of operation. Right? The closed loop gain for this system is 1 plus Rf by R1. 40 by 1, that is 41. Closed loop system is 1 plus Rf by R1. What is the maximum amplitude of the input? 0.2 volt. Maximum amplitude of the input is 0.2 volt. Now directly use this formula. But always change the unit of this. This is the 2 volt into 10 raised to power 6 volt per microsecond. Number of students are making mistake here. They are not changing the unit of what slew rate. 2 into 10 to the power 6 volt per second, change the unit. What is the closed loop gain? 41. And what is the VM here? 0.2. 0.2 here. Now you will get this is the maximum frequency where we are not going to get the distortion. No doubt, if the frequency is greater than that, we will get the output, but with the distortion. So what should be the frequency? It should be less than omega m. Or if you want the answer in what? Hertz, it should be divided by 2 pi. You will get the answer in hertz. So what is the precaution here? Change the unit of slew rate. 2 into 10 to the power 6 volt per second. It is normally it is unit is what? Volt per microsecond. Hope so that concept is clear. That is the question on what? Slew rate, on maximum frequency of operation. Now, what is the answer for this one? What is the answer for this question? So I am giving my Telegram channel link. If you want the PDF of this session, then quickly join my Telegram channel. Okay. So what is the link here? I am sharing. Yes, please. Electronics by Sanjay Rathi. Already I have shared the PDF of all previous 3 classes, and what today we have conducted one mock test for you. So you can download that PDF. Already I have discussed some important numericals, right? And some authentic sources. Okay. Now that is a question on what operational amplifier. Again, the input is given to positive terminal. Their feedback is connected here, RF, and this is the R1. Again, it is a non-inverting operational amplifier. The gain is what? 1 plus Rf by R1. But what is given here? An operational amplifier has ideal characteristics, except that its open loop gain is given by expression this one. Ideal characteristics means Ri is infinite, R0 is 0. That is the characteristics, except that the gain is given by 10 to the power 4, 1 plus 10 to the power minus 3. S means j omega. This operational amplifier is used in the circuit shown in the figure. That is the operational amplifier. The 3 dB bandwidth of the circuit in radian per second. In radian per second, 3 dB bandwidth is required. Now, remember, what about the operational amplifier? Operational amplifier is a direct coupled amplifier. Direct coupled amplifier. Right? Once it is a direct coupled amplifier, what about the frequency response curve? This type of frequency response curve we will get. Right? And that is the frequency response curve here for operational amplifier. Now, this is called cutoff frequency. Higher cutoff frequency is nothing but the bandwidth of the direct coupled amplifier from this point to this point. This is the FH, and FL is 0. For direct coupled amplifier, always remember FL is 0. It will pass the AC as well as DC signal. AC plus DC. It will pass both the signals. But ultimately we can say it acts as what? Low pass filter. Yes, it is a low pass filter. And that is the gain of the low pass filter. Actually, it is a gain of the low pass filter. Now, when I am representing this gain, AV is equal to 10 to the power 4 upon 1 plus 10 raised to power minus 3s. Now, compare with the standard one. A maximum divided by 1 plus j omega by omega c, cutoff frequency. You can replace the s by j omega. It will become 10 to the power 4 upon 1 plus j omega upon 10 to the power 3. This will become 10 to the power 3. Compare these two equations. When I am comparing these two equations, what is the gain here? 10 to the power 4. That is the gain, 10 to the power 4. And what is the cutoff frequency? Omega c, 10 to the power 3. This is the cutoff frequency. Higher cutoff frequency is called cutoff frequency. It is in radian per second, so I am writing in radian per second. This will become omega c. What is the value of omega c? 10 to the power 3 radian per second. Compare these two equations. That is a standard formula for low pass filter. Now once you will get the omega c, what is the gain bandwidth product? The gain bandwidth product will become, gain is 10 to the power 4, and what is the bandwidth? This is called bandwidth. Bandwidth is the band of frequency for which the gain is almost independent of the frequency. There is a variation in the frequency, but there is no variation in the gain. So what is the bandwidth? 10 to the power 3. So what is the gain bandwidth product? 10 to the power 7 radian per second. 10 to the power 7 radian per second. That is the gain bandwidth product for given operational amplifier. Right? Now tell me, what is the gain for when I am applying the negative feedback? Because in this diagram, we are giving negative feedback. Actually, we are giving negative feedback. Right? It is the operational amplifier. Here we are connecting the negative feedback. This is RF, this is R1, this is connected here, input is connected here. And because of the negative feedback, the gain will reduce. What is the gain here? Closed loop gain. 1 plus RF by R1. 1 plus, this is the 9, this is 1, and therefore 1 plus 9 by 1, that is the 10 is the gain. Now the new gain is 10, but the gain bandwidth product will remain constant. What was the gain bandwidth product? 10 to the power 7. So what is asked in the question? The 3 dB bandwidth of the circuit. That is nothing but 3 dB bandwidth. Okay, so 3 dB bandwidth. So bandwidth will become gain bandwidth product upon closed loop gain, or gain with feedback. So 10 to the power 7 upon 10. So what is the answer? 10 to the power 6 radian per second. 10 to the power 6 radian per second, and that is the bandwidth. So this is the question on gain bandwidth product. Remember, it is a direct coupled amplifier. The formula is standard formula, is just like a low pass filter. This is called cutoff frequency. This is called instantaneous frequency omega, or frequency of the signal. Compare it and you will get the answer from this question. Okay guys, चलिए आपके कोई डाउट है तो पूछ लीजिए भाई. तैयार है अगले टॉपिक के लिए? आर यू रेडी टू सॉल्व द नेक्स्ट क्वेश्चन? कुछ तो कमेंट्स कीजिए. ओके देन. कॉपी. नाउ द स्लीव रेट इज क्लियर. Okay, next one, just general question. If something is given in the operational amplifier, don't worry about that. Always we have to apply two things in a negative feedback. One thing is what? Virtual short concept, and another one is what? KCL, and you will get the answer. So that is the example. सभी बड़े ताले जो होते हैं ना, बहुत बड़े बड़े डायग्राम दिखते हैं, तो जितने भी बड़ा ताला है, मतलब आपका लॉक है, उतना स्मॉल की से वो क्या होगा? ओपन होगा. तो बहुत बड़ा डायग्राम जब होता है, बहुत बड़ा जब एग्जाम होता है ना, तो हम लोग पहले डर जाते हैं. और याद रखिए, डर के आगे जीत है. राइट, रिमेंबर दैट. बहुत सारे आपको अभी लगेगा 1.5-2 महीने में कि क्या मैं एग्जाम निकलेगा या नहीं निकलेगा, प्रॉब्लम क्या होगी, तैयारी हो पाएगी या नहीं हो पाएगी. अभी किसी स्टूडेंट ने पूछा सर कितनी नंबर ऑफ सीट्स आएंगे. ऐसे बहुत सारे आपके दिमाग में क्वेश्चंस आएंगे. बस याद रखिए, आपको एग्जाम में अच्छे से परफॉर्म करना है और एग्जाम निकल जाएंगे. ये बड़े बड़े क्वेश्चन भी ऐसे छोटे छोटे ट्रिक्स से सॉल्व हो जाते हैं. तो देखो इसमें क्या पूछा है. Assuming the ideal operational amplifier, the output voltage at V1, here it is a V1. In the figure shown is, it is only 1 mark, a numerical answer type question and 1 mark question. Only 1 mark question. Right? This is 2 volt is given here. Try to solve this question and give me the answer. This is the 3 volt is given here. Negative feedback, because this point is connected to negative terminal. This is the negative feedback. Ideal operational amplifier is given, and that's why virtual short concept is valid. Again, here it is negative feedback. This point is connected toward ground. This point is connected to ground. So there is no negative feedback, and that's why for operational amplifier 1 and for operational amplifier 2, virtual short concept is valid. Okay. Then when we want to solve this question, so this is the VN1, this is VP1, this is VN2, this is VP2, this is 2 volt, this is 3 volt. So VP1 is equal to VN1 is equal to what? 3 volt. VN2 is equal to VP2 is equal to what? 2 volt. You will get the voltage at this point. What is the voltage at this point? 2 volt. What is the voltage at this point? 3 volt. Now, voltage at this point you have idea about that, voltage at that point you have idea about that, and voltage at this point is what? V1. But we can't apply the KVL at this point. Remember, some student will apply the KVL at this point. They will write V1 minus 3 by 1 plus V1 minus 2 by 3, and they will get the answer 5 kilo ohm. That is given. Okay, but that is the wrong approach. Why? Because we are not having the idea about the current here. Definitely there will be the current. There will be the current in this path. But current enter into the operational amplifier is 0. Because the input resistance is infinite, that's why we can apply the KVL at this point. And this is the ground. KCL, sorry, not KVL, KCL at this point. KCL, we can't apply the KCL, Kirchhoff's current law, at this point because we have no idea about the current. The voltage at this point is V1, we have to find the V1. Now, KCL, input current is 0. Apply the KCL at this point. When I am applying the KCL at this point 3, so 3 minus 0 by 1, 3 by 1 plus, that is the 3 minus 0 by 1. Remember, this is in kilo ohm. 3 minus V1 by 1. 3 minus V1 by 1. What is the current enter into the op-amp? 0. 3 minus 2 divided by 1 is equal to 0. Now you can take LCM 1. 3 plus 3 minus V1 plus 3 minus 2 is what? 1 is equal to 0. So 3 plus 3, 6 plus 1, 7. What is the value of the V1? V1 is equal to 7 volt. V1 is equal to 7 volt. That is the answer for this question. Okay. Okay, proper KCL, apply the KCL and you will get the answer for this particular question. Now, if you have the idea about the V1, what is the V1? 7 volt, and suppose what is the current is asked. Now you can apply the KCL at this point and you can find the value of the current at this path. What is the value of the current here? So now you can solve it. So sometimes they may ask what is the current here. Okay. Now next question. What was the topic? Initially I have given, I will cover role of operational amplifier in biasing. So biasing and stabilization of BJT, we are using the operational amplifier. That is the role of the operational amplifier. It will stabilize this BJT. That is the question. Tell me, this is the MSQ 2 marks question. It is MSQ and 2 marks question. Operational amplifier is given 5 kilo ohm, 10 volt, 1.4 kilo ohm is given. Right here the value of the VBE is given as 0.6 volt. VBE is 0.6 volt, means this is the base terminal and this is the voltage V at the operational amplifier output. This is the base terminal and that is the emitter terminal, and VBE is given as 0.6 volt. Beta is not given in the question, means beta is very large, and that's why the base current is 0. And then you have to find, you have to give the answer which are correct. Which are correct? Tell me. This is connected here. This is the positive terminal. That is the negative terminal. Now, 5 kilo ohm, 10 volt, 1.4 kilo ohm. Monday I have one session. Please note the time at 7:30 to 8:30. Waveform generator, where I will discuss astable multivibrator, monostable multivibrator, bistable multivibrator, questions on symmetric trigger, right, and triangular wave generator. So note the time 7:30 p.m. Monday. You will get the notification, subscribe our channel. Now this is the 5 kilo ohm, 1.4 kilo ohm, this is the 5 volt. Tell me. Now, when we are saying that that is connected to what? Positive terminal, simply we are saying that the feedback in the circuit is what? Positive. If we are giving the positive feedback, then virtual short concept is not valid. We can't apply the virtual short concept. Second thing, in this diagram, the feedback is not positive, feedback is negative. That's why this point is wrong. Feedback is negative here. So when the feedback is negative, right, we can apply the virtual short concept. This is the Vn, this is the Vp. Vn is equal to Vp is equal to what? 5 volt. Vn is equal to Vp is equal to 5 volt. Now, at this point, this is the Vc, collector point. Vc will also become 5 volt. Vc will become 5 volt. What is the current enter into the operational amplifier? 0, because the input resistance is infinite. What is the current here? 0, because the beta is very, very large. Beta is very, very large. And this Vb is given as 0.6 volt. We have to find the V voltage at this point. Now, if this is the Vc is the 5 volt, we can find the Ic. And the same current will flow here, Ic. That is nothing but IE. Ic is equal to IE because base current is 0. Once you will get the IE, you can find the value of V. V is equal to, now you can apply KVL in this path. When I am applying the KVL in this path, it will become V is equal to 0.6 plus IE into what? 1.4. Now what is the IC is equal to IE is equal to 10 minus Vc. 10 minus 5 divided by 5, 1 milliampere. Now you can put V 0.6 plus 1.4, that is nothing but 2 volt. The voltage at this point is 2 volt. Any doubt here? No, this is the 2 volt is the answer. Voltage V at the output of the operational amplifier is 2 volt. That is the correct answer. Feedback in the circuit is not positive. It is negative feedback. Power dissipation across the 5 kilo ohm resistor is 5 millivolt. This is the 5 kilo ohm resistor. So what is the power dissipation across the 5 kilo ohm resistor? IC square into R. What is the IC? 1 milliampere. 1 into 10 raised to power minus 3 square of this into RC. What is the RC? 5 kilo ohm. 5 into 10 raised to power 3. 10 raised to power 3, 10 raised to power 3 cancel out. You will get 5 into 10 raised to power minus 3 watt. That is the power dissipation across the RC. It is what in, what is this? Milliwatt. 5 milliwatt. And that's why this answer is also correct. Right. The voltage V at the output of the op-amp is 0. That is wrong because already we have proved this is the 2 volt. The answer for this question is BC. Answer for this question is what? BC. Here the operational amplifier is used for stabilization of the transistor. How? Simply watch this diagram. MSQ, they may ask one MSQ on that. Then let this is the VI. Let this how it will stabilize the transistor. This is the VP, this is the VN. And why I am saying that there is a negative feedback. This is the VP and this is the VN. The voltage gain is operational amplifier is AV. No doubt we are saying that infinite, but practically it has gain. Then VI will become VP minus VN. Remember, VP is nothing but VC. VP is nothing but VC and VN is fixed value 5 volt. And the output of the operational amplifier, that is the V0, or sometimes it is known as VA, this one. VA, voltage at this point, or this is nothing but base voltage, VB. Base terminal voltage. It will affect what? VB. Then V is nothing but VB. Output of the operational amplifier, that is given by AV into VI, that is AV into VP minus VN. Okay. Now watch this. What is the voltage at this point? It is IC. Same current will flow like this. So what is the VC will become? VC will become VCC minus IC into RC. Actually, this is the RC and this is the VCC. VCC minus IC into RC VC. Now, try to understand why there is negative feedback. Why there is a negative feedback? Simply, when the temperature increases, what about the reverse saturation current? IC is equal to beta IB plus 1 plus beta times of what ICU. When the temperature increases, reverse saturation current increases. Therefore, IC will increase. And that is called biasing problem. Because of the temperature, Q point is unstable. Temperature increases, IC increases, VC decreases, Q point is moving towards saturation. That is the problem. But what will happen in this circuit? When the temperature increases, ICO increases, IC increases. But once IC increases, what about the VC? Since IC increases, it is multiplied with the RC, and that's why the VC will decrease. When the VC will decrease, what about the VP? Because VP is VC. So positive terminal voltage will decrease for the operational amplifier. When the VP will decrease, what about the VI? VP minus VN. So VN is fixed at 5 volt. VP minus 5. So VP will decrease means VI will decrease. When VI will decrease, everyone tell me. Once the VI will decrease, AV into VI, output of operational amplifier will decrease. And what is the output of the operational amplifier? VB. VB will decrease. When the base voltage will decrease, definitely the base current will decrease. And when the base current will decrease, what about this term? This term will decrease means IC will decrease. IC will decrease, and that is the temperature will try to increase the IC, but this path will reduce the IC so that rise in IC is compensated, and that is called what? Biasing and stabilization of this circuit. Right? And what is the role of the operational amplifier? My dear, the gain of the operational amplifier is very, very, very large. And that's why if there is a slight change in the gain, if there is a slight change in the IC, slight change in the temperature, that will noticed by the operational amplifier and it will increase, because that is multiplied by what? 10 to the power 6. Because the open loop gain, operational amplifier, the gain is what? 10 to the power 6. That slight change is multiplied with the 10 to the power 6, right? It will take action, it will give the negative feedback, and the current will remain stable. Okay, that is. So in this way we can explain this diagram. There is a negative feedback in this diagram and biasing and stabilization problem. Okay, so that is the question. So this is a very, very important diagram in a GATE exam. This is no doubt, it is a previous year question, my dear students. Watch each and every previous year question carefully. The given, you have to solve the given question as well as you can anticipate which type of question they may design on the same diagram. Right? क्या होता है ना, ये सब स्टैंडर्ड डायग्राम है, तो स्टैंडर्ड डायग्राम पर उन लोग क्वेश्चन और अच्छे से डिजाइन कर लेते हैं. आप उसकी डिटेल में नहीं जाओगे, वो कुछ और डिटेल पूछ लेगा. फिर जब आप गेट देकर आओगे, उसका सॉल्यूशन देखोगे, उसके बाद फिर पढ़ोगे, तो अगले साल कुछ और डिटेल पूछ लेगा. तो आपको पहले तैयार करना है कि क्या पूछा जा सकता है. ओके, दैट इज द आंसर एंड दैट इज द एक्सप्लेनेशन ऑफ दिस सर्किट. नेक्स्ट वन. नाउ लास्ट टू क्वेश्चंस ओनली, लास्ट टू विद इन 5 minutes. ओके, circuit shown simulates the relation V0. This is the I think this circuit is visible to you. This is the R2, this is the R1, this is the V2, this is the V1. 6 kilo ohm resistor here connected. R2 and R1 is not given in the question. Output is given as minus 2 V1 minus 3 V2. The value of R1 is 3 kilo ohm. The value of R2 is 2 kilo ohm. The value of R is 1 kilo ohm. R is connected to reduce the effect of input offset current. MSQ, 2 marks. Multiple select question. Which answer are correct for this question? Yes, give me the answer in comments box. Then, okay, what is output is given? V0 is equal to minus 2 V1 minus 3 V2. Right. Take a screenshot of this. V0 is given as minus 2 V1 minus 3V2. Okay guys, then this is a R2, this is the R1, this is V1 is connected, V2 is connected. It is a summer. Actually it is a what? Summer. It is just like a summer. Here we are connecting the R, right? Now, first of all, when we are solving the question, don't worry about this R. I will give you the explanation for this R. So it is just like an inverting summer. So what is the output? Minus RF by R1 into V1 minus RF by R2 into V2. That is the inverting summer. Minus RF by R1 into V1 minus RF by R2 into V2. Now you can write minus 6 divided by R1 into V1 minus 6 divided by R2 into V2. Now you can compare the equation number 1 and equation number 2. Minus 6 by R1 is equal to 2. Therefore, R1 is equal to 6 by 2, 3 kilo ohm. Then 6 by R2. 6 by R2 is equal to 3. Therefore, R2 is equal to 6 by 3, 2 kilo ohm. Now you will get the value of R1 and R2. What is the answer? The value of R1 is 3 kilo ohm, right? Value of R2 is 2 kilo ohm, right? Now, why we are connecting R here? Why we are connecting R at the non-inverting terminal? That is the important question for what? Instrumentation branch, electrical branch, because in instrumentation we have to calculate the input bias current, right? Input offset current and so on, right? That they will affect the performance, and that's why we are connecting the R. Actually, R is connected here to reduce the effect of input bias current. To reduce the effect of input bias current, right? And what is the input bias current? Remember, if this is an operational amplifier, to balance it, we are passing two separate current here. One is called IB1, one is called IB2. This is called bias current. So that for open loop operational amplifier, output will become 0 when the two terminals are connected to ground. That is called balanced operational amplifier. Then the input bias current is called IB1 plus IB2 divided by 2. That is another question. What is the input bias current? The separate current entering into the operational amplifier to balance the op-amp, that is called average value of this current is called input bias current. And what is the offset current? Offset current is difference of these two. Offset current is difference of this current. So this is the bias current, that is the offset current. So we are connecting R here. We are connecting the R in this diagram. 1 minute. Right, R here to reduce the effect of input bias current. So what is the value of this R? The value of this R is nothing but DC resistance seen by the inverting terminal. This is the keyword, DC resistance seen by inverting terminal. Inverting terminal. So what is the theory? We are connecting R to reduce the effect of input bias current. And what is the value of R? Input resistance seen by the inverting terminal. What is the meaning of this? First of all, make the output 0, that is balanced. Make the V1 is equal to 0. Make all the input signal is equal to 0. Now, put here, that is the Vn. Which resistors are connected? R1 ground, R2 ground, and RF connected to what? Ground. All are connected in parallel with respect to Vn, with respect to ground. That is called DC resistance seen by the inverting terminal. And that's why the value of R will become R1 parallel with R2 parallel with RF. R1 we have calculated 3 parallel with 2 parallel with 6. Find the parallel combination, you will get the 1 kilo ohm. You will get the answer 1 kilo ohm. That is the question. The value of R is 1 kilo ohm. The value of R is 1 kilo ohm, right? And R is connected to reduce the offset of effect of input by offset current, wrong. It is connected here to effect of input bias current, right? Input bias current. Okay. So that is the question. Finished. So this is about the input. So please get the idea about that. What is the input offset voltage, input offset current, input offset voltage? There may be question on that. Okay. Thanks, Gopi. Okay then. Now last one. Calculate the total offset voltage for the circuit. Calculate the total offset voltage for the circuit of the figure for the operational amplifier with specified values of the input offset voltage and input offset current IIO. Input offset current IIO. Right? Remember that again the R is connected here. Then there is no effect of input by what should be the R? RF parallel with this resistor. Tell me. 5 kilo ohm parallel with 500 kilo ohm. So what is the nearly value? 5 kilo ohm. 500 kilo ohm, that is a too high. So 5 parallel with the 500 is nearly equal to what? 5 kilo ohm. So already 5 kilo ohm resistor is connected here to reduce the effect of what? Effect of input bias current. So there is no effect of input bias current, but it will not reduce the effect of what? Input offset current. Input offset current. There will be the effect of input offset current. Right? So what is the answer here? How we are going to solve? First of all, if the VIO is given here, if the VIO means there is a voltage developed because of the circuit components and other dissimilarity. Actually, it is a differential amplifier, but we can't connect the same type of elements. That is the internal problem of that. And once we are connecting the negative feedback, both the terminal are connected to ground. Again, we are getting the some output. That is called the effect of input offset voltage. So when there is an input offset voltage VIO, then there will be the effect. Because of that, there is no input. Again, we are getting the output 1 plus RF by R1 into what? VIO. VIO. Because the effective circuit is given by, this is the VIO and this is the non-inverting operational amplifier. Input is, there is no input. Again, we are getting the output 1 plus RF by R1 into VIO. Okay, no problem. So what is the VIO is given? 4 milli, 505. So it will become because of offset voltage, it will become 1 plus 500 divided by 5 into VIO. What is the VIO? 4 millivolt. What is this? 101. I think 404 millivolt. 404 millivolt because of input offset voltage. Without any input, we are getting the output. That is the effect. Okay. Second thing, input offset current. What is the output because of the input offset current? Remember, when we are connecting the 5 kilo ohm, then there is no effect of input bias current, but here we are getting the output because of input offset current that is given by IIO into RF. This is the RF. IIO into RF. So what is the IIO? 150 nano ampere. 150 into 10 raised to power minus 9. What is the RF here? 500 kilo ohm. 500 into 10 raised to power 3. So what is the answer? Right. So 1, 2, 3, 5 and you can calculate this value. Okay. So this is the value. Now, very simple calculation. You will get 0.075 volt. Now you can convert it into what? Millivolt. Yes, you can convert it into millivolt of 75 millivolt, I think, na? 75 millivolt. Now add these two. What is the effect of input bias current? Worst condition. What is the worst condition? That is unwanted. That is also unwanted. 404 plus what? 75. 404 plus 75. That is the output voltage. check my calculation. This is the effect of what? Input offset voltage, and that is the effect of input offset current. We are getting the output without any input. Wanted or unwanted? Unwanted. ठीक है ना, unwanted है, but again we are getting, no problem, but it is a very less as compared to the coming output. ठीक है ना, थोड़ा थोड़ा देखो अभी क्लास चल रही है, थोड़ा बहुत नॉइज आ रहा है, बट वी कैन टॉलरेट दैट. अगर वो लिमिट को क्रॉस करेगा देन वी हैव टू टेक सम एक्शन. ओके देन, so this is about the input offset voltage, input offset current. Already I have discussed important numericals on that. I think I have covered all the topics here mentioned here. So this was the course, right? Slew rate, voltage to current converter, differential amplifier, logarithmic amplifier, filters, gain bandwidth product, use of op-amp, offset voltage and currents. Now if you want to get the idea about the all pass filter, then in today's mock test already I have discussed one question on what all pass filter. On my Telegram channel, that is Electronics by Sanjay Rathi, already I have uploaded the PDF. Go through that, you will get the idea about that. What is the use of that, and already I have solved one MSQ on all pass filter. Okay, so this is all about my session. Already I have covered all the topics. All the topics are over. You are on BYJU'S Exam Prep. Thank you for attending the session. Thank you very much. Like the session, subscribe our channel and share the link of this session. Thank you and good night.